humanity needs to go to space in general, and the first step is the moon. But they need to do that to avoid like the nihilistic perspective. Like if we just stay on Earth and the sun dies and we die with it, like everything was meaningless, I think. And like, yeah, maybe our conscious, like we have individual meaning, but I think we could have so much more meaning if we last longer than our cradle, which is like the Earth. Like we need to go and do other things.
Hello and welcome to episode 9 of Beyond Me, the show where mechanical engineering students go beyond ME, and where the things we talk about are beyond us. We like thinking broader, we like thinking deeper. I'm Ben.
I'm Liam.
I'm Finian.
Today we talked with Luke, our guest, about moon colonization, space, future of humanity, and relativity a little bit.
Yeah, we're on video now, so go check us out on YouTube or Spotify. Give us a like, comment, or review. It really helps us out. Let's get into it.
All right, Luke, thanks for being here. Do you want to tell us a little about yourself, just to begin?
Yeah, thanks for having me. I'm a second-year mechanical engineer student in college.
Like all of us.
Yeah,
Yes,
actually,
similar to the Beyond Me hosts. I'm definitely interested in space, and I would definitely like to work in aerospace is like the life goal.
So aerospace engineering, that's what you're kind of working towards?
Yes.
And you also, what do you do besides schoolwork at RIT?
I play Frisbee
Whoa,
with
that's crazy.
everyone here.
The four of us are all mechanical engineering students and play Frisbee. What are the odds?
We need to branch
That is
out.
not
Yeah,
a coincidence.
But yeah, Luke, I mean, I'm just kind of curious, what first got you interested in space? Like, were you a little kid, you're like, that's cool. Like, tell us a bit more about that.
Yeah, so I'd like everyone, I'd say like space is pretty like incomprehensible as a little kid, and so I definitely thought that it was cool to try and comprehend that. And I like to think of myself as a smart person, and so like when you get to high school and stuff, and you start taking like physics classes, it becomes like a lot more in reach, and it was very fun to like learn about this stuff. And that's like I like to consume like physics and space media in my free time for sure. And yeah, I've always kind of wanted to like work in space, like engineer, which like kind of made me choose the engineering path. I used to just think that like building something that went to space was cool, but I'm definitely a lot more ambitious now about my chances of like going to space and for the very least as a tourist, yes, for sure.
How long?
That seems pretty doable,
Yeah.
right? I mean, but
Well,
yeah.
how long do you think it'll be? You said like as a tourist. How long do you think it'll be until like tourism happens?
So
What
yeah,
already is happening.
That's a great. It is already happening.
Well,
I
like
think for the general public.
Exactly.
Right?
So like the
No, I
cost.
think it is.
No,
How
the-
much,
Am I wrong
how
with
much
that?
does it
Like,
cost?
really
general
Bezos
public.
doesn't have
Who has like
tickets
$1
for like
billion
$200,000
to...
That's still
for
like
to go to like Leo or something for a little bit. Or,
yeah, and that's fun, but like just to like go up and down, like
Yeah.
barely go above the
You mean,
Kármán
like,
line.
for a space
it's
station?
gotta
Yeah.
get to the point that airlines are at, where like a plane ticket is
Yeah.
like, and it's like that's still gonna be ridiculously low. That might not happen during our lifetime, but like low 5 figures to go to space, that's totally at the very least I think gonna happen in our lifetime.
That'd be pretty
That's
sick.
crazy.
And so you want to do that, and you also want to be working in the industry, right?
That would be perfect. Yes, that would be very ideal if I was to work in that industry. And yeah, like the co-ops I'm trying to get and stuff, like definitely trying to work towards that.
Do you have a specific space company
Yeah.
you're looking at?
Yeah.
Well, there's a few. I got an interview from GE Aerospace at the
Nice.
career fair. They
Nice.
said, screw you, which,
Hey,
I'm fine with.
GE, if you're watching this podcast, you missed. Come on,
Yeah,
you missed
what do
a
we
good
do at
opportunity.
GE? That's
But yeah,
Let's start that.
I recently had an interview with Amphenol Aerospace, which was really fun, and they have like they're a big like electronics company, but they have like connectors and stuff. They call them on like the ISS, on like SpaceX's Starlink. So they're like really involved in that stuff. And it's like if I get that job, that would be crazy.
Yeah, I think a lot of the companies are like, you don't necessarily know the name, but there's so many companies that just make parts for
Exactly.
SpaceX, for
Yeah.
NASA, for whatever, that are equally as cool. Well, maybe not equally as cool, but yeah. Is there a specific type of thing that you want to work on in terms of aerospace?
That's like, yeah. So I thought that would be like an easy question to answer because like back in the day, it was like you want to build something that goes to space, you build a rocket, and like that's it.
Yeah.
But now, and especially if we do like go to the moon and stuff, like you could do almost anything in like work in space because like the moon is gonna need like even like basic machining, like doing machining on the moon is gonna be like a key to like colonizing it and stuff. And so like a lot of engineering things that like aren't rocket science are like very feasible things that I could do. But we'll see.
So you're not you're not even saying like to necessarily build the things that help us get to the moon, but just like work on the moon to like what's the
Yeah, would you want to work on the moon?
I
That would be
would. I
cool,
definitely
yeah.
would. I don't. So like this is where it gets. I'm confident in saying that like low Earth orbit for a low 5-figure amount will be doable. And the thing is like the moon is an incredibly like the hardest thing is getting out of Earth's orbit. And once you do that, like things like going to the moon are so much easier. Like, did you know it's if you start on the surface of the moon, it costs like way less energy to get to the International Space Station than if you start on the surface of the Earth. So
I mean,
like
that makes sense.
yeah, Willem,
Right,
you can
less
fact check that. But but like it's really just we need to do it. Like it's like you guys were talking about AI. I was watching Big Sam's podcast, and you were like the math is already there to use quantum computers. Like we just need to like build them, and like
Well, I mean,
it's analogous.
We went there in the 60s.
So
Like, what's
Right.
up with that? What are we doing?
Yeah.
so
Do you have any thoughts on that?
yes, I do. So the space race is basically just the pyramids. It's just a society doing something crazy to prove that their society is like the best. So
Just to leave a legacy or to
yes,
that's
and
the
like
pyramid's case.
we could have built a moon base then, and a lot of people probably would have died doing it because like it's just not safe. And like God, the Apollo missions, like those astronauts are insane for going up on a spaceship that has less computing power than the iPhones in our pockets. Like they were not safe, and like there was no reason to build a moon base. There was no reason to even go to the moon other than to beat the Soviets. But like now we're approaching the point where capitalism is going to take over, and it's just going to be like NASA right now has a plan to go to the moon, but they're like, if you look at their rocket, even it just looks like a bigger Saturn V. Like they're not like improving in the way that private companies would dare to do. And like they just need to, the government needs to take the back seat on this and let private companies do their thing, which is like make money by like doing stuff, which is like go to space.
Well, that's the question. Where I've wondered, like, where is the money? I think that's part of the reason we haven't seen as much development in the last, 60, 50 years is because there's not, like, what you can maybe get resources somehow or develop scientific equipment up there or tourism. But other than that, like, what is the potential economy of the moon?
So that's a really good question. So like the benefits of going to the moon, right?
Yeah.
So the moon is like, it's crazy how useful the moon is.
Really?
Yes. So the moon is like 40% like silicone. It's like 20% like calcium, and there's like magnesium. There's iron on the moon. It's crazy that we think of Earth and like we think of the ground, and it's like this crappy dirt. It's like this soil stuff, and dirt is like as rare as life itself. Like because the dirt has been created by life, like shedding, like crying, like dying and like breaking up, and like that's happened over so many millions of years that the Earth is covered in this like really weird stuff that we call soil, and no other celestial body that we know of is like that. And so the ones that are rocks, they've been hit by asteroids for like millions of years. And so like the moon, for example, has all those things, but there's like asteroids that are like built out of like lithium, or like there's diamond asteroids out there. I think there's an asteroid that's made completely out of diamonds that's like bigger than the Earth itself, and we've like found that.
Really?
And so
Somewhere
like
out in
there
space.
is, yes, and so like those are pretty far away. But like going to the moon is going to be great because a lot of what we need to build on the moon is like made of the moon.
Okay.
It's kind of like this treasure chest. It's like as soon as we get there, we just have all the resources to continue building there.
And like the first
okay.
thing that's going to happen is like moon real estate is going to be like what
That's
kickstarts
huge.
it. Because once you like take some trips there and you start building habitats, which at the beginning can just be like boxes of like iron, or like we're gonna use steel, but like steel boxes that you bury in lunar regolith to protect yourself from like
Wait, in what?
the radiate. So like the moon has iron on it. The one thing that we're gonna have to import is carbon, because there's no carbon on the moon, unfortunately. There's like very little.
Okay.
The moon, it has like everything though. Like there's, I was saying there's like 40% silicone, like 20% calcium. There's like,
Is there any oxygen?
so like I'm saying silicone, all these things are oxides. So the
okay.
most
Yeah.
abundant resource on the moon is oxygen, which
Okay.
is
So
pretty
that's really
crazy.
nice.
And so yes, like the oxygen's already there. We just need to do electrolysis with the lunar regolith, and we're going to use calcium anodes, which calcium's already on the moon, so it's easy. And that's going to be able to separate everything in the lunar regolith. So you just got to heat it up, which is, again, going to be easy because there's no atmosphere. So you just use the sun, and you can get really hot temperatures. And this is definitely not my area of expertise, because the chemistry, I'm just not interested in chemistry.
Yeah.
But like it's doable. It's very doable.
Wait, and you're saying this needs to be done to get the oxygen to breathe, or?
So that it'll be, the oxygen will be a byproduct of this. So let's say
Okay.
you want to build a steel box, a nice simple habitat. So you take like the regolith, you heat it up
And sorry,
by
what's the regolith?
regolith. So this
the
is
stuff?
So like this is what the moon is made out of. And like the top
okay.
little bit, there's like dust on the moon, because when you get hit by so many asteroids, it breaks everything up, and over millions of years you get these little dust particles. And so lunar dust is really annoying, but like it's not all dust, it gets like bigger and bigger, and it's like that little, like the lunar soil, even though it's not soil like Earth, like that's regolith. And so that is like the easiest. So like we're gonna have to excavate a lot of, and it sounds very arrogant to say like the thing that all these like cultures of humans have been looking up to, like we're just gonna dig it up and like it's just feedstock material. Like it sounds arrogant to say that, but like I think it's so much better than staying on Earth, and I think that's a big part of why we should go to space.
Do you know, are there any materials, like you mentioned silicone, are there any other really expensive or valuable materials that would actually be worth exporting back to Earth? Like what, or I guess we'd have to get the cost of transportation. Is there like stuff undone?
So
do
yeah,
you know?
that in the moon, like not really. There's not like gold on the moon,
Yeah.
but the moon,
Well,
what
there's
the
cheese on
moon,
the moon, right?
Yeah, geez.
what the moon should be is our like jumping off point to go and get all that stuff, because it has such low gravity and has no atmosphere. The no atmosphere is actually probably the more important part, because your ships don't have to be aerodynamic at all.
Yeah.
So you could just like launch a space station from like the surface.
So most of our space development can be
Yes,
from moon.
it
That's
would
what
be
you're saying. Yeah.
once we set up there, like there is economically, other than getting people off the Earth to the moon, like there's no reason to launch anything from the Earth.
So it's like a checkpoint kind of
Yes,
thing.
yes, it is our doorway to like
Yeah,
the
that's
rest
really
of the
interesting.
universe.
I've never heard that.
So like, say there's now like a colony on the moon. What would like the transportation, like there's all these people on the moon and there's all these people on Earth. What's the transportation looking like between the Earth and the moon?
This is where it gets fun, because so when you're on the moon, there's a lot of things you don't have to worry about. Like you don't have to worry about gravity's a lot less of a problem, and you don't have to worry about the atmosphere, which is so massive. So whereas there's this idea of single stage to orbit vehicles on Earth, and they kind of look like planes sometimes because you got to like fly them up. And it takes a lot of energy, and it would be really nice if it didn't, but it does on Earth. But for the moon, rockets are all about like getting as much like tons. The number that matters is like mass to low Earth orbit, and I guess per like energy used or something. And so we have to just expend so much energy to get it out through the atmosphere, because you can't go too fast, because then the atmosphere like pushes against you too hard, and you can't go too slow or else you'll never escape Earth's gravity. and so we have to go like up into the side to like start orbiting. So so what we do on Earth, I guess, is like we try to stage 0 is like the launch pad, right? And so we try to like put as much as we can into that. We try to like light the engines using the launch pad. You try to like push fuel into the rocket until the very last second, even when the engines have started firing, just so you can bring the most energy with you. And so on the moon, we can do a lot more with the stage 0, like with stuff that isn't the rocket.
Wait, did I just misunderstand you? They're fueling the rocket before it's
Yes.
actually left.
So
Is that why the like tower doesn't move away until
Yes,
like
yes.
ignition?
And you see
really
like the
cool.
quick
That makes
disconnect arm
sense.
and like it
Yeah.
like falls off. Like
Wait, and
Wow. So that's just that. So you're gaining that much energy that's
Yes.
dispensed just to get it the first couple
yes,
feet and
because
get
like
the first
those
little bit of
first
speed.
feet are
Yeah.
like you use so much to
Yeah.
just get it
oh,
off.
so
Okay.
okay,
Going
okay,
from
okay.
0 to like
while,
a little bit.
while it's moving, it's already used fuel. You're putting more fuel in.
Yes.
Okay, that's
That's
cool.
pretty
Yeah.
cool.
And so this stage 0 idea on the moon can get us so much further. So like, yes, we'll start initially probably with just like what we think of as normal rockets, but there's no point in putting the energy to get to orbit in the rocket when you could have it on the moon. And so what that might look like, so orbital velocity for the Earth is like 11.2 kilometers per second. It's pretty fast. For the moon, it's like 2.5 kilometers
And
per
that's
second.
the speed that you need to be able to escape Earth's orbit.
Yeah, so like when you're orbiting, like you're always falling, and so you got to go forward more than you fall to like stay in orbit.
Okay.
Yeah.
And so that's a lot less around the moon
Right.
because
Less
they have
gravity.
less gravity. Yes.
Wait, so is that like the ISS speed? Or
Yeah,
I can't
so the
remember. That's-
ISS, yeah,
It's like
goes-
17,000 miles an hour or something, right?
Yeah, that
Or-
sounds right. But yeah, it would have to be going orbital velocity, and the ISS loses a little bit of height each year because like
Right.
the atmosphere never really ends.
Right.
Like there's still some parts per million up there. All right, but back to stage 0. So what stage 0 might look like on the moon is the one idea that I really like, at least, is imagine like train tracks.
Oh, like maglev?
Yeah, and well, so it could be, but the idea isn't like that. Doesn't really matter. The idea is that you speed it up to 2.5 kilometers per second on the moon, which isn't going to be hard if you have a flat surface with wheels and like you have train tracks to keep you going straight because there's no air pushing against you. And then you just give it a little like little push up, and now you're going orbital velocity like 1 meter above the moon, and then you just like go up a little bit, and like you're already in orbit. And this rocket
That's
hasn't
really
used
cool.
any of its fuel.
Wow.
Well,
Wait,
how
so
does
there-
it initially get up to speed though?
So
from the
you just
tracks.
have to use like some power.
Oh,
but like
maybe
that,
they'll,
that's
Like if you
belongs
had
to
like
the-
a sled that was still
Okay.
connected. And
Gotcha,
then
gotcha.
Yes.
So like a powered rail or
slingshot.
something.
some power source on
Yes.
the moon that's
Yeah.
not. Okay,
yes,
got
but
it.
some like initial cost that isn't. Once this infrastructure gets set up, the idea is that like the cost of that energy being used isn't going to affect the ticket price of someone who's trying to ride this plane, because it's like the business that ferries you from low Earth orbit to the moon. Like they're going to recognize that once they set the system up, hopefully they don't raise the ticket prices to insane amounts, because like the actual trip from the low Earth orbit to low moon orbit, I guess, is like very cheap. And so hopefully that's what we end up like paying for.
Wait, but you were
So
saying
most of the expenses, you're just saying from 0 to low Earth orbit, like from
Yeah,
Earth.
that's like always going to
order.
be expensive. And so how you get that cost
Sorry,
down
go ahead.
is by bringing like 200 people per trip. But
Yeah.
yeah. So what were you saying?
So you were saying like on the moon you just have some sort of like maybe rail system get it up to speed very easily because you don't have drag, but on Earth you do have drag. Is it just the same thing but it just costs more? Like
No, so Earth we're always going to do like straight up.
okay, so that's not
Yeah.
that's not gonna okay.
There's a company that they have this little package, and they have this massive like gun, and they try to like shoot things into orbit.
Have you seen spin launch?
I think that's what I'm
Spin
talking
launch
about.
is pretty
But
cool. Well, that's where it just spins it around.
oh,
up
okay,
until,
so
Yeah,
that's
spin launch is
that's
But
neat.
you can't put humans in there.
you definitely
Yeah.
can't.
Yeah.
'Cause yeah, like the G's you pull
Yeah,
are
too
insane.
many
And
Gs.
have they actually gotten anything to orbit?
I think they might have. I think
so.
they've done.
I think they got close.
Yeah,
Willem,
okay.
can
yeah,
you check on
let's
that?
get a
Yeah.
fact check on
I
that.
don't know, but even if they did, they can't put like 200 people in one of those
yeah.
things.
Yeah. Exactly.
Right.
They would become sauce.
Yes.
So it's about like efficiency packing as many people into each trip.
To getting out of low Earth orbit, yes. And my idea with like if you speed something up on the moon to get it into orbit, once you're in low Earth orbit, it should be very cheap and simple to get from there to a place like the moon.
Does the moon have any atmosphere, or is there a little bit of gas?
There's no, so like basically none. There's like stuff in space, but like solar radiation has long ago stripped away anything that was surrounding the moon. So like when an asteroid crashes into the moon, some stuff's going to get vaporized and some gravity is going to leave some of the heavier stuff there. But solar radiation, the moon's magnetic pole just isn't strong enough to protect it. And so like there is no atmosphere. But it's why like Mars has like 7% of Earth's atmosphere, but it's still got something there because it's like big enough to protect some of it.
So it's in kind of like an equilibrium where it can keep that much, or
I
is
actually
it
don't
losing some?
think this is like the limit of my knowledge, but I think Mars is losing its atmosphere because Mars didn't used to be red; it used to look like Earth. Like there used to be oceans on Mars.
Yeah.
Oh, and then it froze, right? Or is it?
I think most of the water like evaporated.
Oh.
That's a good question.
I think it also evaporated. So
that makes me think it evaporated more.
And so, is the goal for colonizing on the moon just to be like the step between going to other places, or is there also a goal to start a colony and have regular people live there? Like, what's your thought on that?
I would love that. I love the idea of like a lunar like country. I guess. I just think like that is a bright future for humanity. Versus,
and like self-sustaining, completely ideally.
Exactly.
Yeah.
Well, like, do you think it'll be like its own country, or do you think it'll just be an amalgamation, or do you think it'll start as a bunch of countries and then the people,
it's gonna have
to. The moon.
It's gonna have to start, and I think over time, if they do get like self-sustaining and they start like doing their own things and like having their own culture, like they're gonna want independence eventually. Like eventually. The first human is going to get born in space, and then the first human is going to get born on the moon. And I don't know if it'll
fight them.
Exactly.
The Earth and the moon will
I don't know if it'll take this long, but there's going to be people on the moon who haven't been to Earth, and there's going to be like a lot of people who see the moon as like their home. And why would they want to be under the flag of the United States that they've never been to?
Well, they also might not be able to come to Earth because of gravity.
That's like, that's a great.
Like, how do you compensate for having so much less gravity on the moon?
That's a great question.
It changes your body over
like
time.
We won't know until we go there or let
like
these things happen.
Developmentally, they're gonna evolve to be a different species.
Oh, they're gonna look different. Yeah, they're gonna evolve probably really
quickly. When like you're in space, like your muscles atrophy, your bones start to decay. All of this stuff happens to your body because it's essentially like, oh, I don't need to be maintaining all of this because I'm not under 1G. This is just a waste of resources for me.
Right, and the astronauts that we send there now do maintain it because they do exercise and whatever because they plan to come back to Earth.
Yeah,
but if they're not planning to come back and they don't need to,
But even it doesn't work. Like exercising isn't enough.
Yeah.
So the real solution is probably gonna be rotating space stations that have 1G of gravity, and that's where you sleep.
Has anyone made any progress on artificial gravity other than just rotating things? Is that completely science fiction?
I think so. Because we have to bend space to do that, which is
that'd be tough.
Which I do want to talk about a little bit later.
Yeah, we do.
So Luke, what's your number one reason of why? Besides, if you think it would be cool, why we should start colonizing the moon.
So I could give you
All right, you can give me multiple reasons.
I'll give you this. So it's about one big thing. I think about humanity needs to go to space in general, and the first step is the moon. But they need to do that to avoid the nihilistic perspective. If we just stay on Earth and the sun dies and we die with it, everything was meaningless, I think. And maybe our conscious, we have individual meaning, but I think we could have so much more meaning if we last longer than our cradle, which is the Earth. We need to go and do other things.
Because compared to like how old the Earth is. We're like a speck.
Yeah, and like if the Earth is like an American adult male, it's like 59 years old, and adult American males live till like 79 or something. And like we've only been on Earth for like a second, if that. I think that's like
Wait, so you're saying Earth is almost at the end of its lifespan?
yes, it is.
It's what we're like 13 billion years in. Is that the sun?
That's
Four
the
billion.
universe.
That's the universe. Okay.
That's the
Four,
universe.
4.5 or something,
Okay.
right?
How much left do we have of Earth as it is?
We have
now?
like 1 billion, I think, which
We
sounds
have
like
some time.
So it's-
but-
We'll be able to get
we have
off
some time, but
planet Earth then, right?
there are so many events that have happened in Earth's history that have brought biology like to its knees. Like we
Yeah.
think of the dinosaur impact, but like mammals survived that, and there's been so much worse than that. And like back when there was only bacteria on the Earth, which bacteria arose like almost as soon as it could, and it's been like brought like I think the like 80% of all life has been exterminated at one point, and that's like I think there's been like at least 5 dinosaur type like impacts, and so like that's one of many reasons. Like now we could just press our big red button and we could all kill each other, and like so there's more reasons than asteroids that we could all end.
So that's just the probability of that goes down if we spread out.
Yeah, like
we
even
put
if we
people in
have a
space.
billion
Yeah.
years, we should not take that for granted.
Yeah.
So like I see no reason to procrastinate going to space as soon as it's like economically viable and like we can do it.
I mean, just the odds that we don't have a nuclear war in a billion years just feels like impossible.
Well, also
I don't
like
know,
like world-ending events like you were talking about, Luke. Like the super volcano that's under Yellowstone is supposed to erupt, I believe, every like 200 million years, and we're around 100 million years overdue.
We're also
Oh.
due for like an ice age. Like we're due for a bunch of different stuff. And
So
like
we're cooked. Is
Yeah.
What
and like
is
yeah,
what I
and like
hear.
a gamma ray could come out of nowhere and just fry the entire solar system like at any time. Like we wouldn't know until that happened.
What's a gamma ray and where does it come from?
It's like suns, stars.
Pulsars.
Okay.
Yes, so like very energetic stars will like release these gamma ray bursts as they're called, and they travel at the speed of light. So like we wouldn't realize it was happening until it reached us, and it would just completely obliterate everything. Like gamma rays are the most energetic form on like the light spectrum, which is like radiation. So like there's X-rays, are like pretty chill. Gamma rays are like not chill at all.
So like one of these bursts hit the Earth. What time frame are we looking at? Weeks, days, months?
Well, like
Was it
since
instant?
it hits, or what do you mean?
Yeah,
Like-
like it hits the Earth. How much time?
like no time.
Like it just
we're
fries, it
gone.
just instantly
Like
fries
seconds.
everything.
Like our DNA is dissolved. Like we're gone.
And
That's crazy.
would that chance go down if we're in the moon? Like,
No, so this is why like Elon Musk wants to go to like Mars. Not because he thinks it's out of range of nukes, which I find completely ridiculous. Like if we want to nuke Mars, we're gonna find a way to get a nuke there. But like a gamma ray burst is big enough that like anything that hits Earth is gonna catch the moon as well. Like these are very,
oh, but Mars could be safe if it's in the right
I don't
orbit.
think so. I
phase? Oh,
think
you don't-
any
no?
any gamma ray burst the entire solar system is done.
Like if it's sufficiently far enough away, it's like a laser pointer.
Yeah, exactly.
Sufficiently
It's
far
spread out.
away, it expands to a diameter that's far enough.
And like all stars are sufficiently far away.
Yeah.
It just like the odds of it happening are the odds that it's pointed in our direction when it happens.
Yeah,
If that happens, it's over.
So, how do you feel about Mars? Notice you just mentioned that. Do you think we should colonize that?
I think Mars as the first step is ridiculous, and I don't think Elon Musk believes we should go straight to Mars. Maybe he sends his starships there in 2026, but Mars, like we can only go every 2 years because of how the planets align, and it's just like not that much better than the moon in like any way, other than just another celestial body to colonize.
it takes a lot longer. How long would it take for us to get there?
It depends how much you're accelerating, but like
Well,
the Starship, like it's gonna take like 5 months.
Yeah.
Okay, so not unreasonable.
No, not unreasonable.
What if
Well,
we
that's
use
5
like
months in space, and
Yeah.
if it's not going to be rotating, that's 5 months in
Yeah,
zero
exactly.
G.
Oh,
And
it's a
with
long time, but
radiation, yeah. Like
wait? What
it's-
if could we do some kind of electric, solar powered, or nuclear powered propulsion system that
Nuclear would
allows
be that
us
answer.
allows us to accelerate the whole
Yes,
time?
if we get nuclear, and that's a big thing about what will make the moon economically viable is if the ones on the train tracks taking off, they have
Yeah.
nuclear engines, they can like last forever with like zero cost.
And so would that be nuclear to like ion? I don't know how
I don't really know how nuclear engines work.
electric
either.
propulsion works.
Yeah.
Or-
So they like shoot really small things out the back, and it's just
Yeah.
like really efficient because like they turn it all into like velocity. And the thing about nuclear is you would accelerate the whole time until you're halfway, and then you would
around.
decelerate. And so that I think nuclear would take like 10 days to get to Mars.
Yeah.
Like something crazy like that.
I think you might be talking about an ion drive.
Yeah.
Yeah, that's
But ion
Sounds-
drive would be powered by a nuclear reactor or something
Yeah.
like that. So yeah.
Yeah.
Yeah, so much faster. But
Yeah, but like ions, like really small stuff that you shoot out the back, and it's like really efficient as opposed to like combusting methane and like shooting all that crap.
because
out.
like combustion only converts what like
Not everything.
0.5% of the actual energy that's within something, whereas nuclear is like 1 to 2%, and then like
Yeah.
on the other end is like an antimatter matter reaction's like 98%, which is just like insane. It's
That
You
is,
just said a
but-
lot of words,
Would
and I
be
want you to
fire.
tell me more about those words.
so like the total energy when you're converting like E equals mc squared. When you convert mass into energy, using like combustion, like coal powered power plants, I believe are only converting like less than 1% of the actual mass energy that's within coal into usable electricity.
I looked it up once. It's really
I
small.
mean, that's
it's way less
incredibly
than 1%.
inefficient.
Yeah.
Yeah, it's crazy how inefficient it is. And then nuclear is like, I want to say 1 to 2%.
Which is
But-
still,
like-
still to me sounds incredibly inefficient. But
yeah.
And those losses are like thermal, right? Like
Well, it's
is
just
it-
matter. Matter goes in, and most of it comes out as matter, right? Or
Well,
like
it
the thermal
is,
is the energy
it
that we're
is
harnessing.
thermal,
Makes sense.
because you're not able to capture all of that heat and put it into the water that you're using to boil and then turn the turbine. So it is like also the number of steps in between, like what you're burning and the final generator. And then like nuclear is like 1 to 2% because the actual reaction is within the element itself, uranium 234, I want to say
235.
I'm-
235 is
yeah,
like the popular
235.
one.
235. And then like when you're doing antimatter matter, that's almost everything because these two particles are essentially trying to annihilate each other because of reasons.
It's a cool way to put it.
So like opposites, right? Yeah.
Yeah.
Luke, do you know about antimatter?
Oh, it's like not like not sure if it's been proven to be real, but
Antimatter?
is it real?
Yeah, we've made antimatter.
Yeah.
It's crazy how much like energy it takes for us to do it because what it is so like a proton has quarks in it. I believe it's 2 up quarks and 1 down quark, and I want to say antimatter is 2 down quarks and 1 up quark. So it's called anti because it's the opposite. And then for us to flip quarks, we have to put all this energy into like these elemental particles, which are really difficult to get to, and then it's crazy inefficient.
So is like any funny stuff happen with time while we do that? Because like I've heard antimatter get talked about when you're talking about like the speed of light and stuff, and like going faster than that.
Like you might be thinking of stuff with like negative mass
That might be it.
because all of like
And that's
big-
different than antimatter.
yes,
Okay,
Oh,
that makes
okay.
sense.
I believe that's dark matter. Disclaimer moving forward. We're college students.
Yeah.
We're not fully versed in
Yes.
like any of the
I don't
topics
want to
that
spread
we're we
misinformation.
don't want to spread misinformation, but this is what I remember. So if you're going to be taking this and being like, oh, this is what it is, double check what I'm about to say.
Don't write
'Cause-
your thesis on
Yeah.
this.
I believe it is dark matter. and all the big physics equations work with negative mass. They still work out to like the same
And negative time.
and negative time.
That's beyond me.
Yeah.
That we should definitely talk about
me,
that.
me and Finian were talking about this. I believe it was last night,
Was it last
or
night?
it might have been 2 nights ago. And I was like, all right, we're having Luke on soon. Let's just have a preliminary conversation about some of this stuff because I just kind of want to see where Finian's at because I know that I'm not like I don't know a lot about this stuff. And I think that the point that we reached was we know that negative mass exists because mathematically it should and blah blah blah. And besides that, we could not tell you more about.
We haven't
this.
found it.
Okay.
It theoretically can exist. We think that it should exist, but we haven't found
And
it.
by we, like
Scientists.
Scientists.
Like when you're looking out into the universe and being like, oh, the universe is accelerating its expansion. Something has to be pushing it out.
okay.
We just don't know where it is, what it is.
So for the record, we might not know a lot about we might not know a lot about this stuff, but neither do scientists. So I think we're okay. Like we don't have to worry about that too much.
Yeah, it's like when like dark energy like, causing the expansion of the universe. It's like I think it's a really bad name because we don't know if it's energy, we don't know if it's dark. Like it's just the name we've given something because things aren't moving the way they should according to Einstein's equations.
So it's a black box. Something is happening. Assign it a name because we want our math to work and we need to have it in there to make it work.
Yes.
So we put it in there.
And like the scary part is that in theory, like 90% of the matter in the universe is like this stuff.
Yeah.
Yeah.
It's so, yeah.
Which is like what? We don't even know what this is made out of. Like, and everything we see is normal matter. But like apparently that's a tiny fraction of like what there is.
We don't like know how it behaves either. So it could like pass through this room and we wouldn't know about it.
Yeah,
Wait,
like
aren't-
higher dimension stuff.
Do Einstein's equations also show that black holes are like portals to other universes? I feel like I've seen that. Is that?
Yeah, so like they're kind of because the concern is that like black holes delete information. Apparently, Stephen Hawking like proved that they have entropy, but I don't really understand any of that. And it's like the classic understanding is that like black holes, you can make them out of anything. Like I could throw you into a black hole and there would be no way of like you know when you say like you burn wood, you could technically like collect all the smoke and all the stuff and like put that wood back together. Like in theory there's no way to like take everything out of a black hole and put it together. Black holes, they're summarized by like 3 numbers, I think. Like they have electric charge, angular momentum, and mass. And the issue is that none of those numbers reflect what the black hole is made out of.
They delete information.
Yeah.
It seems like it, yeah.
No, but I've seen like where you take like a space-time graph and you like bend
and there's
it
the
and then
white
you're like,
hole on the other side.
yeah,
Yeah.
exactly, and you pop out the other side. Is that
Probably
subtle?
not.
That's a whole like theory about like like quote unquote the multiverse because like when you pass in, so it's sort of think of it as like a wormhole. When you go in, you're supposed to sort of like be put out in another place, like
Another dimension, right?
yeah. I'm not going to talk anymore about it because
Yeah, that's
I don't want to say something that's like wildly wrong.
Yeah. Well, and just for the record, black holes are just basically things where there's so much gravity that even light can't escape. Is that the
Yeah. Like infinite curvature of the space. And I think wormholes are like different than black holes in that black holes curve like into a point. Whereas wormholes, like in theory, there's like a little, you can get through them. It's like it doesn't go to a point, it goes to like a tube and it spreads out again. That's like you're in the new universe,
Gotcha.
in theory.
Luke, can I ask you a question about light speed? I don't know if you know the answer to this, but I've asked multiple people. I've never found
I
a
know exactly what you're gonna.
satisfying
I know you're
answer to
gonna
this. Okay, so speed, as far as we know, is all relative to something.
Yeah.
I'm running relative to the ground or driving relative to Earth. If I'm out in space, not near anything, what is governing my speed? Why is it light speed?
Well, so in like our space, like there's always going to be something. Like imagine you in an empty universe with just you. Like the speed is meaningless in that universe.
So I can.
Speed is only relative to other things. If you were moving infinitely fast in that universe and you weren't moving at all, like there would be no difference in anything.
Right. So then what if, okay, let's put an object, let's put two objects. Why can't I just go from one object to the other object as fast as I want? What is the actual?
Like instantly, you mean? Or like faster
Or
than
as
the speed
fast,
of light?
yeah, if I have some propulsion mechanism that can do
Because
that,
it like breaks causality. And you need another observer to like see the issue. If you're just like you and you got your internal clock, there's no clear reason why you can't travel faster than the speed of light.
So there needs to be an observer. There needs to be.
Because like from
There
an
needs to be some
outside
space.
perspective, you would get to that other object before you left the first one. Because
But why does that stop me from actually doing it?
Because
Like, wait, like.
Because time has to move forward.
No, but like
I don't know.
one thing I've heard is like there's like a fabric of space. Like there's actually like you actually are moving relative to space itself. Is that true, or is that?
I think that's at the limits of what
Yeah.
human knows.
Yeah,
but
that's fair.
I would say that you move relative to like other mass and other things. Like moving relative to space, like there's no set still point in space, because like even if like we're still in our galaxy, like our galaxy is moving. If we're still compared to like the supermassive black hole in the middle of our galaxy, like it's still moving. Everything is moving because it's all relative.
Wait, I got a good one then. If
I know
have,
exactly what you're gonna say.
if I have light going at light speed in this direction and light going in this direction,
Yep.
you're going two light speed away from the other one as one of them. I mean, that's why it's a hard question.
It's
but
always the
yeah.
same. So let's imagine a dude in a spaceship that's got two flashlights pointing in
Right.
both ways.
Yeah.
When he turns on the flashlights, he observes them both hitting the wall, the back and the front of the spaceship at the same time. But an observer who's outside his frame of reference sees it hitting the back first and then the front. And that's like just because of when you move really fast, you're like the spaceship is a little bit in the future and the back is a little bit in the past. And so like I might have that backwards, might be the other way around, but you see the light do different things. And so this kind of gets us into like why this is scary for like determinism. Because like if both points of view are different and they're both equally valid, the only way like that really works is if like all the pages of history are already written and we're just like at a different part in the book.
Well, that's a
like
it
you
goes
skipped
into my
ahead.
free will conversation. But wait, just going back to this just for a second, if we were to make it two physical objects, let's say I'm going 0.9 light speed east and you're going 0.9 light speed west. That's more than light speed.
That's completely
relative.
possible, yeah. So let's
Wait,
add,
but doesn't that go against the idea?
So there's a
of
dude
it's
called
relative?
Lorentz that has his old Lorentz factor that breaks that example. So let's add a third observer to that. You see someone going to the right at 0.9 light speed. You see someone going to the left 0.9 light speed. So
Yeah.
one of those guys relative to the other is going at 1.8 light speed. Like,
Right.
That's impossible, right? So the Lorentz factor is something that you multiply there. So the only input to that is relative velocity. And so that kind of like brings their speed down to less than light speed, because for the third observer, you need extra observers basically, because you need someone who's like at rest compared to both of them to like.
But what does at rest mean?
Exactly. So like at rest is like not at rest. That's a bad, because you can't ever be like at rest as we talked about. But
Maybe at the place where they both started.
so
Interesting.
at like
Someone that's like at rest in as perceived by the point in which both of them.
yeah. So like
move
if you're
from.
going 0.9 light speed to the right, 0.9 light speed to the left, at rest would be 0 light speed compared to both of those.
So like
and it just
if I'm
feels
in
like
between you and then you run to the left 0.9 light speed and he runs to the right 0.9 light speed, compared to me, both of you are running 0.9 light speed.
Sure.
yeah, but compared to the runner, the other runner's going point like so that's why I'm
But
saying
that's
like
not
let's
what
say
you
you have
see, because light
Well,
always
look,
moves the
let's-
same speed. And
Like, what if, I mean, I'm just saying if there's like a governing speed of everything and it's relative to an observer, does this imply that if there's only two particles in the entire universe and they're each going light speed in the opposite directions, that's allowed?
all right, I'm gonna
that-
create some ground rules here. So, space
it off at some
time
point,
is
but-
different from space and different from time. It's its own thing.
Right?
Everything, this table, me, you, everything moves through space time at the speed of light. Everything. It's how much of that is in space and how much of that in time.
Right. Okay.
So, the faster you move through space, the slower you move through time.
Yeah.
And so, like, that's kind of counterintuitive because I thought when you speed up, it's close to the speed of light, and then you come back to Earth, we're in the future, right? So, like, when it's slower, like, your clock is slower compared to a stationary observer's clock. So this is like the twin paradox. Like, we have that one astronaut who's bald. I think his name is Scott Kelly, and he spent some time on the International Space Station. And he has a twin who never went, so he's down on Earth. And Scott Kelly is now younger than his twin.
Yeah. Which is pretty cool.
So for your example, they go. So you have one person going to the left, one person going to the right, and they're at like close to light speed. So when you combine them, it would be over light
Close to
speed.
2 light speed.
Yes.
Yeah.
So like the Lorentz factor, what that does is it says like, no, that's not allowed. in
What
the
that does is they figured out the math wasn't working. And they
Yes.
wanted it to work. So
Yes.
they added this factor.
Well, that's what
Basically,
That's what it sounds like.
Einstein's
Basically,
equation
yes.
sounds like.
I feel like there's probably more to it.
Yeah.
than-
Oh, there's
Definitely
Yeah, yeah,
100%
I don't
more
know.
to
Yeah.
it than us being like, well, there's this thing.
But how much do you know about space time? Because I would love to hear more about that.
Yeah. So like space time. So everything's moving through space time at the speed of light. So like what we call 1 second is like 1 second plus the speed of like the Earth and like the galaxy and all that stuff compared to like something we don't know. It like equals the speed of light somehow. And so you can make like trade-offs, but you can never get to the issue with getting to the speed of light is it takes infinite energy in the equation. So like if you used everything in the universe, you couldn't push something to the speed of light. But if you imagine you put all of your space-time speed of light into space, then you would have zero time. So if you ever heard like photons don't experience time, like to go from the sun to the Earth to like into our eyes, it's like all in an instant for them. Because all their space-time speed is put into space, and so they have no time. And so like you can never cross that barrier, but in theory, if you're like superluminal already and you're already going faster than the speed of light, then like in theory that's
Tachyons.
yes, exactly. And those have never been found or proven as far as I'm concerned, but like they could exist. And that would be like a particle that is going faster than the speed of light and moving backwards in time.
Oh yeah, I
But
see
gotta
that.
But
equal-
isn't it
Well, I
isn't
don't-
it the fact that at that point it can't move slower than the speed of light?
Yeah, so you can't cross that line.
Yeah. So like if you're above that line, you can't then go below that line.
Wait, I don't understand how that would let you go faster than light though, because if you're going completely horizontal on your time, or how is it?
Now
is
you're
time
now
usually
you're below,
below,
it.
yeah.
You're below it. So you can't
So-
cross
on the
back up.
typical space-time graph. Wait, which axis is which?
So it doesn't really matter. Let's do space and time like this. And
Yeah,
so,
you're
you're
going
always at the
completely
speed of light.
you're going completely vertical if you're going photon. You're not
Photon.
going at any time. You're just going space.
Yes.
Yeah.
So if you're going that direction, how do you go any faster than that? If you keep going over, you're not increasing your.
So like it all
Your
equals
speed.
it all equals speed of light, which is like space and time. So like that graph is like a big circle.
Right.
And so like you can like that graph has points on like the bottom of the circle.
Or
Right.
a circle, or is it a diamond?
So the diamond is how Einstein originally like figured out that like this is probably going to happen, but it turns out when you do the study, like because we're moving pretty fast around the Earth, but like there's no time dilation happening. So like the circle is like I guess opposite of like exponential, but like crazy things only happen when you get really close to the speed of light. It's not a linear relationship.
Yeah.
Okay.
Okay.
So yeah, and it is like a perfect circle, I think.
We should throw up some diagrams.
Yes,
maybe.
like a visual.
Yeah, I'm gonna let
Visual
our
art tool.
video editors. handle that one.
We'll have to do
Yeah.
that.
Yeah.
That's me.
Yeah, but so like if you stay on Earth and I take off in a really fast spaceship, so like everyone has their own internal clock, right? So our clocks right now are synced. Let's say we were born at the same time. Our clocks are synced. And if I
Wait,
go,
sorry, is this like a theoretical thing or is it like a biological?
like for
idea.
theory, this is like how time works for an observer.
This is like a thought experiment.
yeah,
Okay,
exactly.
I can buy that.
So, but let's like in real life, atomic clocks have been used, and one atomic clock was kept on Earth. One atomic clock was sent to the ISS and spun around a bunch and it was going faster. And that atomic clock read a lower number than the one back on Earth when they brought it back. It's like that atomic clock got younger. And so like the issue I'm trying to demonstrate here is if I fly away and my clock gets slower, but like my now is still the same time as your now, but they're at like different moments. Like how can both nows, like the math says both nows are equally valid. Like this is like cosmic, like whatever.
Like there's no correct now.
Yeah. And so how can that be other than all like, how can my future be your now other than the future is already determined? Like, is there
Whoa.
another way?
Well, okay, when you're traveling close to the speed of light, my understanding is that your time perception slows down, right? And
Yes.
so when you go back, your clock, whatever, would read a time that's less than the observer if you start at the same time. But I mean, you're not going back in the future, right? You're slowing down.
Yeah.
Yeah,
So
yeah.
you're
I guess you could think of it like a freezer. You put something in the
We're gonna
freezer.
get a great analogy right here. What do you focus
I'm
on?
off with analogies. Well, let's see if I can.
No, I want to see
Figure
where the
this
freezer
out.
goes.
So when you're accelerating to the speed of light, that's when you've put it into the freezer and it's getting down to like 0 degrees.
Put what in the freezer?
Like I don't know,
popsicle
something
or-
perishable.
Okay.
And it's able to stay in the freezer a lot longer because it's not like decaying. And then
Okay.
when you take it back out, it'll start decaying at the same amount of time as it originally was.
So okay.
That probably didn't make any sense.
No.
I think that makes
yeah,
it-
Keep going.
So when you go to the speed of light, like what Luke said, photons, they don't experience any like passage of time as they move through space, right?
yeah.
Yeah, because it's all instant for them. So everything around them is moving super quickly. So like if you're moving at the speed of light, everything around you is, say you could like look out the side of your spaceship, everything around you would look like it's moving fast forward. And
That's like relativity. Yeah.
yeah,
Like for your stationary from your point of view,
From your-
everything else would be moving at the speed of light.
and then from everyone else,
Well, sure.
if they could somehow watch you would be in slow motion. And then when
Yeah.
you slow down, then you're at the same clock. Then your clocks are moving at the same time.
Right, but since you had that portion of it being slower, you're now
You were preserved, and then were able to technically live longer.
right.
in
so
terms of
I
people
have
on Earth.
no problem accepting the math to be like, okay, sure, like I can go through the motions to be like, okay, you go this speed of light, this happens. Okay, doesn't mean I understand it. And I feel
Yeah.
like a lot. It's easy to be like, oh yeah, like okay, well you have the speed of light, like sure, but do you really know what's like? Do you really know what's going
Like,
on?
we won't know
Yeah,
until we
like-
do it. But like for that spaceship example, like what Finian said, you would like slow down. Like me on Earth looking at you going the speed of light in the spaceship, you would like go in slow motion. But like, is your consciousness in slow motion? Like,
Well, that's what I'm wondering. Like if you're going speed of light, you're not seeing anything move by because you're not experiencing anything, are you? I mean, like you're.
So yeah, if you're going the speed of light, like no information can catch up to you. So like this is like what happens when you fall into a black hole. The observer just sees you. You just sit on the edge of the black hole and like you don't move.
Yeah.
Yeah, but if your speed of light, you couldn't even be moving around inside your spaceship, for example. You would just be. I mean, the spaceship, I guess, can't even go the speed of light. But right, like if there's no time passage at light, like as soon as you press the light speed button, you stay there until.
Well, it's not
That's a
that you stay
convenient
there.
button.
It's
Light
that
speed's end
think
door.
about it as in like everyone else moves around you. Like I think you'd be able.
No,
to
but
move.
is this why you can't go light speed? Because you can never
you
actually
can't go
get
light
there.
speed because it takes infinite energy.
Yeah, or wouldn't it take infinite time too to get up to light speed?
I mean,
Well, if you can't do it, then I guess.
so yeah, like you could accelerate forever and like you would approach it infinitely and like never get there.
Asymptotic
Yes.
Yeah.
situation.
Like
I
you
guess
would
that makes
never
sense
have
then.
enough fuel to like actually get there.
And did Einstein figure this out? Or
Yes, like Einstein built on like Newton. The fastest thing Newton saw was like a horse. So all his it's just like all his equations worked like on Earth.
right.
And Einstein saw like these really like, and then Galileo invented the telescope, and he had some things to say about Newton, which I'm not entirely sure. But like Einstein used Newton and Galileo, but he applied it to like really far away, really fast things, and so he was like, oh, this doesn't really work. Like things aren't where they should be. Like gravity must be something different. And so he's like, oh, maybe it curved. Like how Einstein made that logical leap. I will never.
Must have been
know.
on something.
But like, yeah, like we need another Einstein to like move physics further again, I guess.
I think it's interesting how you were talking about Newton. Like fastest thing he saw was a horse, so everything worked. When I was in high school, I took an AP physics class, and my physics teacher, on the first day of class, he's like, we're gonna learn a lot of things in this class,
Yeah.
and none of those things will be true. Like everything we will learn is like not true, but it's gonna be so close
Yes.
that it doesn't matter.
Yeah.
And I was just like, well, by the way, Mr. Plank, if you're watching this, like, great teacher. But yeah, it's interesting to think about like the reality that you know for your whole life, and then to think about like none of like it's not what's really going on, but we just don't really have the capability. Like
We've
at
had
least
to
us.
simplify it for us to be able to use it in a practical way,
Yeah.
because we don't have a way to merge like all of the different areas of physics into one.
Like a unifying equation. We're still
still working on that.
Yeah, in the search for that.
It's still in our homework to-do list.
We've been
The
working
Notion
on
page.
that for a while.
Yeah.
I think some people say
Not a lot of
Einstein's
pro-
equations have been holding us back, and it's because you can't veer too far off them to actually find anything else
Yeah,
that
like-
could unify us. Because I don't know if that's true. I don't know if you have any thoughts on that. but-
Yeah, like we treat things as laws until like they're broken, and we're at the point where like we're gonna need to break like black holes. Like they clearly break Einstein's laws. It's
Yeah.
like we need new understanding.
Yeah.
But that's the problem with having like mathematics and science. It's too regimented and too stuck in one way of thinking that any research that goes too far out maybe
And this is
gets
like
too much scrutiny or maybe not enough. I don't know.
you guys have all heard of like string theory, right?
Yeah.
Yeah.
And it's like it
But
might
it's like,
be,
oh boy.
Oh boy.
it might have some right ideas, but like it's probably wrong. And the issue is like a lot of the physicists have bet their life on this, and they don't want to admit that it's wrong. And so I've heard that be used as a reason as why like physics is stagnating, because
Yeah.
like it's
Ego gets in the way.
Yes,
Yeah,
exactly.
that makes sense. I've heard that.
It is sort of like the speed of sound. When we were first trying to like move faster than the speed of sound, people were like, "Oh, you can't move faster than the speed of sound. It's sound. It's so fast. You can't you literally can't move faster." And then someone did it.
Sonic boom.
Yeah. And then they're like, "Oh, you can move faster than the speed of sound."
Right. So like to Liam's point, it's like we take it as law, and to same as Luke's point, take it as law until it's not. And
Yeah.
It's interesting. Like, I mean, math and the physical reality go hand in hand because they're kind of used to describe each other, right? So like math didn't just exist. Like we observed things and we learned about, we created math to describe the physical world.
Yeah.
And yeah, like, and if we find something new with the physical world that we didn't know before, maybe our math doesn't reflect that properly.
Yeah, it's also like just like you said, we observe things in the natural world and then use math to describe it. If we don't have data about stuff, like we don't know what happens in a black hole, so we can't use math to
Right.
describe it.
It's
We
hard
don't
to
know
get
what
data
happens.
from black holes.
It's like
Yeah.
impossible. Yeah, like that's like
Hey, we have a photo now.
we do.
That's
Pretty cool.
Of
Sort of.
what?
Of a
black
black
hole.
hole.
The
That's a
first
really
one.
bad photo, but
Yeah,
Well,
it's
it's-
insulting. It's like an orange little smudge.
orange ring.
Well, it is like what it was like 12 petabytes of information.
Yeah, oh,
no,
yeah.
that's way too much. That's way too much.
No, I think it took a ton of observing stations, like a ton of time to compile the image. Like
Probably.
Yeah.
I get-
Because it's so big? Because why?
So
because you're getting
far
tiny
away.
bits of light. Like each station's getting a little bit here, and,
Yeah.
and they kind of like strung them all together, like
That's
pieced them all
strength
together.
theory.
Yeah,
No,
'cause,
that's
like,
not string theory.
Yeah, and like black holes by definition like don't release a lot of light, right? So like it's really hard to see them.
Yeah.
It's like this is like
You're
Galileo.
seeing the light around it.
Yeah,
Yeah.
Galileo with his little telescope like never found a black hole. Black holes were mathematically like someone looked at Einstein's equations and they were like, oh hey, if you put this much mass in, you're gonna get like infinite curvature and like this structure should be somewhere.
Yeah.
And then we found them.
Yeah. Well, like the crazy things about black holes, what I think is like the accretion disk. It is like a disk, but it looks like it's enveloping like around and then like above and below, but it's just around. And the above and below is light bending around the black hole. Which is like
This makes sense. This makes sense.
It's
Yeah, to
crazy.
Luke it makes sense.
All right, no, so like this ball that is so strong that it bends light, right? So
Yeah.
when at the event horizon, like light bends into it always. So imagine right above it, it bends like right around it. So if there's the ball with the disc around it, and I'm looking at it from the side, I'm gonna see behind the black hole, the disc that the light comes up and over, and then to me,
But it's not really a disk, though. Is it? I wouldn't that be more of a shell?
the like accretion disc,
Yeah, like
it like is a disc. I don't know, so this, I
like
don't-
the rings of Saturn are rings.
really.
It's like
so
a
it is
disk.
rings.
Yes.
Yeah.
It's only around like the equator.
Why
Yeah.
do things? Oh, it's always. Is it always around the equator? Why do things form disks around the equator? I guess I don't
'Cause they
understand
want
why
to.
that would happen.
Because this is like gravity. This is how like gravity works, I think. But when you make a black hole, like for a lot of black holes that have big accretion disks, it's because like stars like crashed into each other and like they collapse. And there's a lot of crap messed up, like left over from that's spinning around it.
Yeah.
But I guess it's organized because of gravity into nice disks.
Yeah, and that's like really hot plasma that's just like spinning, and it's like if we
As it
did.
Oh,
falls
I
into-
think I get it. If you had another ring of something that was spinning around, it would collide, and whichever one was biggest would stay. You wouldn't be able to have multiple
Oh,
trajectories
definitely
going
not.
around.
Yeah, you can't have
Yeah.
orbits
So
like occupied by
So I guess around the equator is probably what has the most momentum.
Yeah, like
the
orbital resonance is really cool because
orbital resonance.
you can
resonance.
like certain like Saturn's rings, like there's holes in the rings because like there's like certain ratios where matter can't like sustainably just like go around them. It's gonna get like pushed in or out. It's like if you look at a picture of Saturn's rings, like it's not a
They're
disc.
regimented. They're like
Yeah, there's like very
up.
specific lines, and some entire orbits are just empty. And it's like this is because of gravity and like math.
gravity weird stuff.
This is how it works apparently.
I think what I'm learning from this conversation is that there's a lot that there's a lot that humans as a species have figured out, and there's a lot more that we haven't.
Yeah.
Like I
Well,
listened.
we don't know what we don't know. Like we do know to extent what we don't know, but also like when we learn the things that we right now are like, oh, we don't know this. That will also open us up to avenues of like, oh, this causes this, but like why this?
Yeah, it's like we don't know the questions to ask sometimes.
Yeah. Luke, do you have more?
No,
on that?
I was
Or-
just gonna say like and it's not just on this macro scale like space. I listen to some podcasts. I'm very interested in neuroscience, and I've been unsatisfied because I have all these questions, and almost all the answers are like, that's a theory. That's the theory, or like that,
Yeah.
or like
Yeah.
maybe right. There's so much that we don't know, even about ourselves, our brains,
yeah.
let
the,
alone
the
universe.
fringe cases for like anything. It's all just like, this is what we think.
Yeah.
Yeah.
What were you gonna say, Liam?
I was gonna ask Luke how he knows this. Like, do you read books? Do you
I
read
definitely
articles?
used
Do you
to
watch
read a lot more.
videos? Like, what are your?
I definitely like intake a lot of like space science media. I'd say
Hmm.
Yeah.
used to be a lot more books. Like since I got
No,
to
it's short form
college,
content.
yeah. Now I just got if there's not Subway Surfers underneath, I click away. But yeah, like definitely a lot of YouTube. But a lot of YouTube videos are made for like I don't want to be insulting,
Less
but like
knowledgeable
the
people.
layman, yeah.
Right,
And
right.
so
Yeah.
if you want like really good content.
Yeah, where do you get that?
Yeah, it's like there are some podcasts I could give you guys. So it's just like
Beyond Me is a great one.
the top one. There's a bunch like reading scientific papers is like really annoying because like they all sound like super confusing, but sometimes those are fun to read, especially like new ones that are coming out. And I have like cousins in academia who do stuff like that. And it's
And
fun to read their stuff.
So what are some of the podcasts that
Yeah.
you listen to?
Event Horizon's a really good one. Just some
Okay.
dude who has like physicists on and they talk about like their current research and stuff.
Nice.
That's a good one. I forget the name of the other one, which sucks, but I could show you later, I guess. I forget the name of it.
We can also link these in description. So listeners, if you
could.
want to learn more about from people who are just a little bit more qualified than us, then
Yeah.
you can go
Yes.
Do you guys read?
I used to read a lot more. It's sad how little I read now. It's just
Yeah,
too easy with the phone. Like, I could order a book and like it'll get here, or I could search that thing and it's right in front of me.
Books are a
Like,
lot. I don't know.
The problem with like me and reading is,
that. You don't want to do it.
well, I honestly like I do want to, but it's very slow.
so slow.
Like it's I both my parents are like English teachers, and I constantly joke with them about like, oh, if I watch something and if a picture tells 1,000 words and there's 30 frames per second and each frame is a picture, that's 30,000 words a second.
Whoa, that's a lot.
And then they get really mad at me.
So like the information is slow.
Yeah, it's just slow to go through a book and read it, whereas I could watch a video, and then I'm definitely not getting the same like amount of information. Like the information density might be lower, but it's more engaging, and I am much more able to watch. Say it takes like it's a 2-to-1 ratio. Like 2 hours of watching videos has the same information as reading for 1 hour. I would much rather watch for 2 hours than 1 hour, just because it's more engaging.
the book's gonna have better information though. Like you can maybe
Well,
get
if you
like
make
twice as much information.
I'm
on-
speaking of a hypothetical where like all the information from the book is made perfectly into like a video.
Right. We're just
Yeah,
saying
yeah.
it's sheer speed of intake,
Yeah,
not
Yeah, I
like
guess
the
that's
not the
probably true.
quality.
yeah.
I feel like reading is still.
Well, do you think
Got
it's about not the content, but about how you actually intake it? There's something about reading, like
That's
is there a
definitely
difference?
because you're right. Like someone can talk, like you can listen to
Right, it is-
even this as fast as someone can read, or
Yeah,
faster.
like
slower.
the important
But
thing is the retention.
I think retention is definitely probably higher if you read it.
I
Maybe
feel
not.
just
Maybe
how our
maybe if
brains
you're
work.
watching visuals and listening to someone talk about something, but I just have the feeling
Well,
that
if
it's
you
not
have
as
a
good
YouTube
on
short,
YouTube video
that has
with Subway Surfers.
well, maybe that, but it's got captions so you can read it, and it's got voice so you're listening to it auditorily while you read. The combination of those two things, to me, okay, let's not say short form content. Let's just say regular video that has.
I thought you were about to be
captions.
pro short form content for a sec. I was like, where is this
Let's,
going?
let's just say regular video, captions, and voices. I feel like the combinate, like, the way their brain processes information, I sort of can't imagine that it would be worse to have both of those than to just have just one.
Maybe.
I don't know. I think having it said to you like kind of takes away from like the work you have to do to like read a sentence and comprehend. Like I do this all the time where I'm reading books and I have to like go back a page because like, oh, I like didn't.
Yeah,
so,
I like tuned out.
Yes.
Yeah.
And so like I feel like it's so much easier to do on videos. And I think reading, like writing notes versus just like watching a teacher teach, like your brain retains the information.
Well,
I feel like.
I actually think
I agree.
it might be okay. So when you read and you didn't quite understand that last sentence you read, you're gonna go back and read it. At least that's what I do when I do read, which is kind of rare. Versus if you're watching a video and you tune out and don't listen, are you really gonna go back 10 seconds? Like how often do
It's
you?
a lot harder. I think
I 100% go back and.
But I just feel like, at least for me, there's a much higher probability that I'm just gonna let the video keep on playing and I just will have missed that. Whereas if I'm reading, like,
No, it bugs me if I don't get a part of like the process of someone's trying to explain something. I will like go back like even before they started explaining that thing, so I get like the lead into it and how like they like segued into what they're going to be talking about. Like I can't continue moving forward with the video if I don't understand.
But all those things are just so much easier with a book. Time control and starting and stopping and going forward and backwards in the book is just so easy. You just do it. Like time control is then like you can read as fast as you want to, whereas a video has one really preferable listening speed.
Interesting.
And you can speed them up a little bit, but it makes a less quality video. I don't know.
So do you prefer to read fast? Like, what's your?
No, what I'm saying is like, depending on where you are in the book, you can choose how fast you want to go. You can adaptively change your speed, and I think I don't know.
Okay, so if you're watching or listening to this on
is this
Spotify,
like a question to me or is
no, sorry, this is to
like
our
staring at me
to our viewers on Spotify. You can leave a comment. So if you like, tell us how do you
or YouTube.
Yeah, right. Yeah. So Spotify or YouTube, the two platforms that we have.
Spotify has comments.
It has comments and it has video. So if you're on
Really?
Spotify and you're listening to us, you can flick on that video and watch us. So yeah, YouTube or Spotify, leave a comment. How do you intake content and do you go back or do you just let it kind of flow? Because, well, and I guess my answer to Liam's initial question is that I don't read nearly as much as I probably should.
Yeah.
But I think that it's a conscious decision so I'm all about productivity and balancing my life. And I use Notion to do that. And
here we go.
That was sort of a joke. But whenever there's a free chunk of time in my life, I think about what are some things that I could be doing to fill this. I like to be productive. I don't like to really watch, like, very rarely I'll like watch a show or movie like on the weekend, whatever. But most of the time I want to be doing something that I consider productive. And there are so many things in that sort of bucket of goodness that I could pull from. And each one has its difficulty, a time, relevance, how quickly I need to get it done. And so rarely do I find that being like, I'm gonna read this book, because there's a lot of things that I need to get done, and I can listen to that information through a podcast on my way to class. And to me, that's a faster way. I'm not saying that this is a good solution. I think that there is definitely value to reading. There's definitely a difference, and I'm not saying it's a good thing. I'm just saying that's sort of the way that I justify it to myself. I think about what are all the things I need to get done, and it's usually something that in that moment I just consider more important.
I think. Just real quick. One thing about that though is that, and this is actually I think the biggest important piece about books is that books are highly polished, and are just a lot more concentrated quality information than a podcast or any other type of thing. Not to go against this medium, but
an educational video like isn't like, people put so much effort into research and then they make sure that they're explaining it in like a really comprehensive way, and then they actually have to like make sure that when they are making the visuals, it's in a neat and orderly fashion.
I don't think there's any videos that can go as in depth as the most in depth books can about certain scientific topics and many topics. Like I think the best source for most information is gonna be books or papers or something like that.
I feel like debating about the quality of these things is like
You're right. Yeah, this is
because like they could always be better. Like I feel like an even quality book versus an even quality video is what you should be like talking
yeah.
about.
But do they have like if you want to go really in depth on string theory? Do they have any videos that'll do that? Do those exist?
They probably, but you could probably
Do they?
turn.
I've watched some.
The
really
internet's
in depth,
vast.
like that get into all the math.
Like not like the math, but like they explain the pretty in depth about like how it works.
Well,
You could turn like a 20-page research paper into like a 10-hour video, and like
no, but do they do that though?
I mean,
I feel like they don't.
I
Maybe
don't
they-
probably not as because like at that point like academics, if you want to get taken seriously, you don't make a YouTube video. Right?
Yeah, it's
Yeah.
at
like
that,
they could.
Yeah,
I
at
guess.
that point, it's all about. It's sort of about like what's accepted within the world of academia, because you don't see scientists posting YouTube videos about proofs. Actually, that reminded me of one time when someone did.
Okay, one time, but sure. So point is like, yeah, like Luke said, you can't really compare because like there's different people behind these different things. Some videos are great and well polished and well produced and well written, and some are not.
Yeah.
And so I think on average there's probably going to be more care put into fact checking, peer reviewing like your papers. But it's not like a fundamental thing about the medium that makes it that way. It's just that because of the way that it's set up, because the types of people who happen to do one thing or the other, that's the way it is. It's not a fundamental limit to videos.
Mm-hmm.
I want to kind of change topic. Ben said you said earlier that you like to do productive things with your time, right?
Yeah.
I completely get that. Like I hate when there's time in between my classes and it's like stuff where I'm like not doing anything. It's like, what am I doing? But you said, and I kind of want to push back against this because I'm a big movie fan. You said that like you don't consider watching movies or any of that like a productive use of your time.
So okay, I'm glad you brought this up because I didn't like my point, but of saying that was not to be like, oh, people who watch movies or do this like lazy or unproductive. Not at all.
They are to a certain extent though. If you watch like a ton of movies on a week,
but the way like productivity is a relative thing, meaning in any like instance in my life, I will have my own ranking of the things that are going to be the most productive for me to achieve my goals, both short term and long term.
Mm-hmm.
And maybe that could include watching a movie, right? If one of my goals is to relax and be less stressed for the week, on a weekend, maybe that is the most productive thing for me to do. Maybe it's to watch a movie. So I don't mean productive as like your classic like doing homework and studying, right? I think of productive like how is this thing gonna get me closer to my goals? Usually my goals are getting things done, meaning like homework or for my projects or for the podcast. But that could totally be like learn more about this thing or like experience, or like just watch film or de-stress. So it definitely depends. It all comes down to my judgment of what's productive, which I don't think is always going to be flawless, right? Because like I'm always going to have some bias of like, well, this thing might be the most productive thing for me to do right now, but is it going to be the most fun? Like, am I going to get the most dopamine in the short term, right? Because my brain's also kind of considering that, right? It's like maybe in the long term this is great for me, but maybe I kind of really want to do this now. It seems more fun for me, so it's going to kind of skew it.
Yeah.
Well, Luke,
good answer.
Do you watch?
Yeah.
Do you watch a lot of movies? Like, what kind of movies do you watch?
I do watch a lot of movies, and I think I like to watch what I consider to be good movies, I guess. And it's like I think like crappy movies, like I think there's a little point to that. But I think a good movie is like a movie that really makes you like consider things and makes you think and I think watching those has good like tangible value for like developing how you
yeah.
think as a person and like
Yeah.
stuff like that.
Well, and I think movies have their own. Like, I don't think movies are the best place to find scientific or mathematical information.
No.
I think
Probably
movies,
not.
as a medium, are probably best at conveying social stuff,
Well,
as in like how
I
people
think
interact
it's
with
best
each other.
about
I think that's what I think it's-
ideas.
Elaborate.
Yeah.
Like, let's see if I can elaborate. I mean, like, say you really want to make a movie about like, I don't like. Give an example of a movie, someone.
Interstellar.
Interstellar. Okay, Interstellar. The idea behind that is to like make a powerful film about the like connection between family and like how big the universe can be and like how there's stuff out there that we can't possibly comprehend. And everyone coming out of that movie can get that idea from that. Whereas they might not be able to get it from like a book.
Yeah, like
as easily.
I saw Interstellar for the first time last week, actually.
Okay.
Yeah, fun fact. And 100% agree. My takeaway was not, oh wow, like wormholes are this thing, and this is how they
Yeah.
work, and you can time travel, and like you can experience these different dimensions. Like that's not my takeaway. My takeaway is like, yeah, like there's so much more out there than just me, than just us. That like right, there's so much out there. It makes you think broader. We like to think broader. We like to think deeper. We're beyond me.
But it's,
yeah,
it's all about like conveying like either the screenwriter, the director's like ideas about life and like about the world and about anything they want.
Yeah.
Yeah. And like that's the same thing for like shows and stuff like that. Like even though you can have like really trashy shows that don't really mean anything in the long term, it's like, okay, this is just someone's trying to show us how like quickly you can get two people together. It's like, okay, that's not really important, but I can see the message behind it or something.
There's also like an entertainment aspect.
Yeah.
And movies are rooted in how much money they're going to make. So like,
Well, that's
they
unfortunate.
need to sell
right?
movies.
Yeah.
It
why
needs
you
to
don't
be
watch those
interesting.
movies.
And it's like the best movies to me are like interesting and they have good ideas that they like tackle.
and I've heard that you're a big fan of Interstellar.
I'd say so, yeah. Probably my top one movie.
Top
Ooh.
one.
Wait, tell us about it.
Yeah.
It's great. It's
Well,
got
for people
like,
who haven't seen it, like just a quick, what is
Synopsis.
it? Yeah.
Spoiler alert.
Yeah, so it's kind of follows a dad and his family, and the dad has to leave his family to save the species, not the planet, unfortunately. And it tackles themes like love and like our place in the universe and like how insignificant we are, but how we can also like fight to change the trajectory of human being like existence, I guess. So yeah, Ben, did you have like any questions? You said there's like some things you didn't understand about the movie, right, or something?
Oh, sure.
Like,
Like most of it. No. Well, I think that Christopher Nolan, the director, is kind of famous for this. He makes movies that they kind of make you think a little bit. Like Tenet is one of them where I watch and
Tenet is
that
great,
you gotta
but
watch like a million times before.
yeah, and the physics still doesn't make sense.
Yeah,
like he's kind of just wrong.
And do I have a specific question? I mean, I guess I just like don't understand enough about. Well, okay. Well, for one, it's like it's science fiction, right? Like it's maybe based on and what's possible, but it's not like
Yeah, it's been called like the most accurate science fiction. 'Cause,
Okay.
like they tried like with the black hole and stuff, like they tried really hard to make that accurate. But
Well,
Wait, but isn't he in the end like playing with like I was really I was really tired that day, so I don't remember a ton about that movie. But like, isn't he like playing with like blocks of emotion?
yeah,
or
so
not
he
emotion,
falls
or
into
stories?
a black hole, and so
and he goes back to his house.
So here's the thing: there's like these bulk beings that like they didn't the NASA in Interstellar, they didn't find this wormhole. It was showed to them by these things, which we learn.
Like the four-dimensional creatures.
And those
Okay.
creatures we learned to be humans from the future that are like acting back in time, and like some like so like that's just complete science fiction.
Yeah.
Like, remember when they first took off and there was the space time was bent and Cooper put his hand in it and it got all
Yeah,
bendy?
yeah,
Like, that
yeah.
was them, like, manipulating space time to, like, say hello, I guess. Like, cool movie moment.
But
Doesn't really
not-
make a lot of sense.
Yeah.
Okay.
But they can do this. And so they turned the black hole into this, like, 4D recreation of his room. And so it's like kind of like, you know, when he moves through the black hole, you know, all those different paths, like that's him moving through time.
As like a spatial dimension.
Yes, exactly. Because they're it's like we can't imagine 4D. Like, they are 4D. Like, they probably they obviously created this 3D like library for him, but it's like doesn't really make a lot of sense to us because it's like from
Yeah, and I think like no matter what we do, like just as three-dimensional beings, we will just never be able to like fully grasp what 4D really would be
Yeah.
like. Like mathematically it works, right? Like 1D,
Yeah.
2D, 3D, 4D, all
5D,
like
6D.
Yeah, sure. Like mathematically.
Yeah.
s-
I think
like-
string theory has like 12 dimensions.
Yeah, and they're
But like
all,
at a
wrapped
certain
on
point, it
themselves.
just like doesn't really mean anything besides being math and like
Yeah.
being like, okay, that's possible, but what does that really look
So
like?
there's a really cool Minecraft mod actually. So
Ooh.
it's a 4D Minecraft mod. So, you know, you go forward and backwards, W and S. You go left and right with A and D. You go up and down with like jump and crouch. And like, what do you like think the 4D control would be?
My first guess would be time, but because you're asking it, it's
volume?
probably not.
It's like a
volume?
spatial. So you control 4D with the scroll wheel.
Oh,
And so
you
when
meant like the
it's
control.
like scroll, yeah. So it's like scrolling through the fourth dimension, and so
I mean,
the
it's
way
just
we
teleports you to
perceive it
different
is
places,
like
yeah.
the 3D just like changes. So like where there's like nothing in front of, you could scroll, and then there'd be the house, and it's like in this slice of the 4D. It's like a slice of a 4D world is like 3D, and so like I build my house there, and then I like leave that part of the fourth dimension with the scroll wheel, and there's like totally new terrain, and so like that's.
And is that fourth dimension representing time or no?
No, like a fourth spatial dimension.
Oh, a fourth spatial dimension.
Yeah.
Like a good way to think about this is like, have you guys heard of Flatland? Like that kind of analogy where you imagine like people that live in like a two-dimensional space.
Yeah.
And if you had like three-dimensional objects, like you had a sphere in that kind of in that space, it would appear as just a circle, and you can kind of move the sphere up and down, and the circle's radius changes.
Yeah.
That's the kind of thing where if you're moving like a 4D house through a 3D thing,
Right,
it's
right,
kind
right,
of its
right.
aspects of it are changing, even though it's like the
Right.
same
So like
object.
you
It looks
can
like
take
it's
you can take a 2D slice of a 3D situation. So you can take a 3D slice of a 4D situation.
yeah, it helps,
but like-
it helps build intuition on how 4D works. Yeah.
So that's sort of, it was explained well to me by like a 2D representation of a 3D object is its shadow. So sort of like like a tesseract, a 4D shape, when we make it in the 3-dimensional world, that's a shadow of the 4th dimensional actual what it would be.
It's
Which
just
we
like a
can't
cross
imagine.
section. Yeah, it's just like it's just a
so
slice of it basically.
We, by moving it down a dimension, we lose like aspects of what it actually is.
Right.
Which is just like
it's a
crazy.
In this case,
projection
it's
of it
a cube.
into our 3D
Yeah,
space.
and you can only see that slice at the same. So like you can in Minecraft analogy, you'd have to like scroll through the scroll wheel to see every slice of it, and then like in theory you could.
Is there
like,
continuity between the different
Yeah.
3D worlds?
Like,
if there's a tree here, is the tree a little bit different but it's in the same spot?
Yeah,
Is it
things
just-
can't just like immediately appear and disappear. I think.
There's some rules to how they're connected. That's cool.
I think
I'd check that
this
out.
is I don't know. This could be misinformation.
And we're still talking about Minecraft, right?
Yeah,
Gotcha.
and like those modders probably don't know everything. So like yeah.
Right.
Actually, the answer to the universe is in this very specific Minecraft mod.
Yeah.
Let's point the scientists who are really working on this stuff. Let's point them to Minecraft.
Yeah.
We'll say, hey, if you want to learn more about this, just move the scroll wheel.
Get on
The
it.
scroll wheel.
But yeah, Interstellar is really cool.
Funny story about that black hole. They created a brand new rendering engine to create that black hole as accurately as they could.
This is an Interstellar?
This is an
Yes.
Interstellar. That's why the black hole in
I thought you were talking
Interstellar
about the image of the
looks like the image that we
It's
got.
like the most perfectly accurate representation that we have.
Whoa.
They went to like
pretty cool.
physicists and were like, "Hey, like, what's gonna happen?" And then the physicists told them, and they coded a render engine for the scene where they're flying around the black hole with the accretion disk and all of this. And they rendered it, and when they got it, they were like, "This is what we think it'll look like." And scientists used
looks
that.
pretty cool.
Scientists used that for a bit until they got the actual image, and they
Yeah.
were like, "Oh, this is like shockingly close. This is
Wait,
scary."
so the
close."
Interstellar rendering of a black hole was used by scientists as like the best image we have of a black hole until we got one.
Yeah, it was like the best.
Yeah,
visual
That's
one.
crazy.
That's
Imagine
really cool.
like being that, like you make a movie and you're like you care that much about it to make it the most accurate. I mean, even like just the money to pour into it, just for that. We're like, who's really gonna notice? That's admirable for sure.
I think Willem could look this up, but I think each like frame of the black hole took like 10 hours to render or something
Yeah.
like crazy.
Because they're doing like, obviously, like when you create something from scratch, it's not going to be the most optimized, but also like it's doing something that computers never did before. They're like trying to model what would happen to all these particles around
Right.
this black hole and then like render it.
Right. It's like my guess is that in 3D space, since we know a lot about it, there's probably some shortcuts that we can take in the rendering process, some simplifications
Yeah.
that we make to make it faster.
Yeah.
But we probably can't do that for black holes because we just don't know. So we just needed to let it like just render it out.
Yeah,
and just,
kind of like brute force. Like
Yeah.
ray tracing used to have to be brute forced by like calculating, oh, this particle is moving to this point, and then it's going to bounce off here,
Right.
and then it's going to go to
Right.
here. And now you have dedicated ray tracing chips in like GPUs that render these things. And those calculations just go through at 1,000,000 miles a second. Because
1,000,000 miles. Is that your final answer?
Yeah, final answer, 1,000,000 miles a second.
All right, we're getting a real time statistic here for interstellar rendering. Okay, so the answer is state of the art server farm, 100 days to render
a lot.
one black hole.
A third
scene.
of a year.
I mean, even just in energy, how that's got to cost a lot. Well, obviously, like not even considering developing this engine from scratch and like.
Having to figure out how to code it, how to like integrate it into.
Yeah, they probably like visited a black hole and like took some measurements. No.
Yeah.
Well, that's like, did you guys have space books when you were a kid? Like those books that had all the cool images of space stuff,
Yeah.
like planets. I guess I never thought about it, but when I got older, I realized that none of those were actual images of like black holes and stuff.
all
Like,
the planets
oh
just
no,
next to
It's like
each
that was
other.
Microsoft Paint.
yeah. But no, they looked really realistic. So I don't know. but
Well,
looks
they
good.
look realistic to you, who had no idea what it should look like.
They
Exactly.
look pretty good.
Yeah,
My imagination couldn't
yeah.
prove them wrong.
Okay, so we just got word from our PA Chapo. So not only did they have to render the light, like they made it like I guess a rendering engine, as you said, Finian, but they also had to like make their own physics engine because the existing ones just didn't do the right physics that would be applicable in this case.
Yeah.
So I mean, I'm sure a ton of work went into both of those things, which is very cool.
Yeah, I think like I don't know if you've heard of like Universe Sandbox, but like renderings of black holes exist, but they definitely like cheat in like how they do. I don't know like how things are rendered, but I think like this one, like they didn't say like, oh, like no light's gonna come out of this. They like put in like a ton of mass and like
Yeah.
this is what it turned.
Right. Like,
Turned
they
into
didn't
a
they
black
didn't take
hole.
assumptions, or they probably took very few assumptions.
Yes, exactly.
About, right.
Like they like created a black hole in their simulation,
Right.
and like rendered that.
Could you imagine like hitting go and waiting 100 days and it comes back and you like forgot to like
Oh my
unhide a layer and like you're like
Well, like they definitely, like obviously, like beforehand they were like, okay, we got to make sure
Like,
everything's
are we
ready.
locked in here?
Yeah,
Are we ready to
everything's
go?
ready. Hit go, and they don't know how long that's going to take probably.
I'm sure it gives estimates as it goes, but yeah.
Imagine just seeing that like estimate go up.
Yeah.
It's like, okay, 16 days.
Yeah.
18 days.
Well,
like,
yeah, I'd imagine that they did some small scale testing,
Yeah,
for
probably.
sure. So they have some estimates of like, is this going to be a linear or non-linear thing? Like, what's the relationship between complexity and time and all these things? And I feel like you'd also sort of need like a real time rendering, or at least like every so often get some feedback about what it's doing, because like you press play, it goes 100 days, and you have no idea what it looks like the entire time. Like, I feel like there's got to be.
You can most likely it'll spit out like every time that it gets a frame, they most likely would have it like spit out.
Right,
Like, oh, this is what the frame looks like.
right, and so you can sort of pause it if it.
Yeah.
I mean,
if it starts going awry.
and yeah, Luke, this has been a wonderful conversation. Thanks so much for. I mean, we talked about a lot of things. We covered the moon. We talked about.
It's been
about
fantastic
space.
having you on.
Thanks for
Yeah,
having me.
Yeah, it was
relativity.
really fun.
Hopefully we can do it again
Interstellar.
sometime.
Yeah.
100%.
I'll have to do it again.
Yeah, thanks so much.
It'd be interesting to do it. Like, I definitely want to do it more, but in like 3 years when we are like a lot more educated. And
Yeah.
I plan on doing like a physics immersion, and like modern physics 1 and 2 is going to go into a lot of this stuff, hopefully.
I will say
excited to
this
hear
is
what you
definitely
learned.
one of those episodes just because the topics we covered are very sort of at the limit of what we know as humans.
Yeah.
Especially for college students.
Yeah.
There were definitely a lot of times where we
Are
just didn't know the answer.
Yeah.
Yeah.
But
and
I think that
unsure about also what we were saying
Yes.
about something.
Don't write your PhD on what we just said.
yeah. But I think the important part about this is not to be 100% right, but just to facilitate a good conversation
Yeah,
and talk
of
about what we
course.
do know, about what we're curious about. So yeah, and I think we did exactly that.
Yeah.
Well, thank you, Luke.
Thank you.
Thanks so
All right.
much.
Thank
See
you,
on the
guys.
next one. Bye bye.